Students, this is 11th basics class. In this class, so I am going to have interesting concept. I am going to discuss some interesting concept. Not defined forms, undefined forms. Undefined. Undefined forms. So undefined forms. First one, let's have a discussion about infinity. Infinity. When I say, if a person speaks about the symbol infinity, there is a lot of questions and a lot of confusions rises. First thing is this infinity a number? Is that infinity a number? Is it a number? No, it is not a number. Where we use this symbol infinity? For what purpose we use this symbol infinity? So you realize, students, here I am going to discuss in detail infinity. We use this symbol infinity. It is just a symbol. Is it a real quantity? No. Can it possible to see that infinity? No. So you may ask, sir, here, there on the board, we can see that infinity. No, sir. No, it is symbol, that's all. We cannot see that infinity, right? Why we use that symbol infinity? To represent very big, very large quantities. Large quantities means it is unimaginable. The size of the quantity is unimaginable. For example, so all stars, you count all stars on the sky. All stars on the sky. So very big means that cannot be seen and that cannot be done. So all soil particles on the earth. All soil particles on the earth. All soil particles on the earth. Is it possible to count all soil particles on the earth, students? No. We take such a big quantity as infinity. Then is that infinity defined? No, it is undefined. Can it define means that can be said. We can say that defined means right, counting 1, 2, 3 up to 10. Counting up to 10. Is it possible or not possible? Possible. It is defined thing. Or you take 4 by 2. How much is 4 by 2? So 2. It is defined quantity. Defined quantity. We cannot define infinity like this. We infinity define madak barala navu. Some people will say, so number by 0 has infinity. Some people will say number by 0 has infinity. Even I too agree with you. I too take when solving problems or somewhere. If I face this problem, if I come across this problem, I too take infinity only. But exactly it is not infinity. So infinity and 1 by 0, they are not equal. Actually, originally they are not equal. Why they are not equal means infinity is, look at this one. So 1, 2, 3, so on. You will say, we people will say, it will go up to infinity. It will go up to infinity. What does it mean? So what does it mean? First number is 1. Second number is 2. Third number is 3. 10th number 10. 100th number 100. In that way, so the size of the size of the number keep on increases. To what extent it increases? You go think that, students, it may be 1 crore. Is that 1 crore a bigger number? Is there no other number bigger than that? Yes, there is a number bigger than 1 crore. You take that as 10 crore, or you take that as big number. So you can imagine a number whose size is infinity. A number whose size is infinity. Infinity means A number which is largest means biggest. Biggest means that cannot be seen, that cannot be written. So such a big things, such a big quantities. So or we represent that by infinity. We represent that things by infinity, right? So look at this one. It's 1 plus 2 plus 3 plus so on. Is this sum a small number? No. This sum of these numbers is not small. So whose size is very big, very large. Very large means so we represent such a large quantities by infinity. Is that infinity defined? No. So the distance between earth and sky, is it possible to measure such a big length, students? No. We take that as infinity, right? So remember that. So right. Now look at this, students. 1 by 0 is equal to infinity. So why 1 by 0 is not equal to infinity? I explain that. 1 by 0.1. 1 by 0.1, it is 10. 1 by 0.2. 1 by 0.2. 0.01, it is 100. So 1 by 0.001, it is 1000. You continue like that. If I continue like that, at the end, keep on decreasing the denominator. You decrease that to an extent whose size is almost equal to 0. You decrease this denominator number almost equal to 0. Almost equal to 0 means if I take the denominator as 0.0000001, if I take denominator as 0.000001, here I am going to get a big number. Can it possible to increase this? Yes. You go up to infinity. 00 number 0000000 up to infinity. You continue this up to infinity. 0.000001. Here you are going to get a number, a big number whose size, the size of that number is infinity. This is the original concept. That means if denominator almost becomes 0, then number by 0 becomes infinity. Actually 1 by 0 and infinity, they are completely different numbers. But in most of the cases, we take number by 0 as infinity only. That works. I hope you understood what that infinity is. Now I am going to discuss some more. So this is not defined. Infinity is not defined. Not defined means does not exist. Usually we take number by 0 as infinity. Though these two are not exactly equal, but for most of the problems, in most of the cases, we take that as infinity only, right? Next concept. So next, one more concept. 4 by 2. You take this 4 by 2. 4 by 2. Is it defined or not defined, students? Defined. 4 by 2, defined, is defined. 4 by 2 is defined. So defined. Look at this, students. 4 by 2 is defined. So right, 3 by 2, 1.5. So right, defined or not defined? Defined. So in that way, if I continue like that, actually 4 by 2 means division means so distribution. So this is actual meaning of this one is distributing 4 apples among 2 people. If I distribute 4 apples equally to 2 people, each will get 2 apples. If I distribute 3 apples equally among 2 people, each will get 1.5. Right? Is it possible to distribute 1 apple among 0 people, is it possible to distribute one apple among 0 people? 0 people are exist or does not exist? Does not exist. What does it mean? 1 by 0 is not defined. Not defined. Not defined. So we take that as infinity. Number by 0 as infinity. One more, students, look at this. So 0 by 0. 0 by 0. Look at this one more, not defined. Not defined. So again it is one more not defined form. 0 by 0. Not defined. Not defined. So this means distribution of 0 apples among 0 people. Is this work possible, students? Is it meaningful or meaningless? Meaningless. Meaningless. Distributing 0 apples among 0 people means it is meaningless. That's why it is not defined, right? 0 by 0 is not equal to 1. Usually 2 by 2 is equal to 1. But 0 by 0 is not equal to 1. Keep that in mind. 0 by 0 it is not defined form. So right. Next. Infinity by infinity. Not defined. Infinity by infinity. Not defined. So I give one example, students. So is this work possible? Dividing infinity by infinity possible? No, not possible. Because you take this example, you take all soil particles on the earth as one infinity, you take all stars in the sky as one more infinity. You go for dividing that, is it possible? No, not possible, never possible. These works cannot be done, we cannot do that. So cannot do that means not defined, we cannot do that. Infinity by infinity, not defined, meaningless forms. So we cannot do these things, meaningless. One more, infinity minus infinity, again not defined. So not defined. Infinity minus infinity. So in most of the cases, 2 minus 2 0, 3 minus 3 0, 0. So right, infinity minus infinity, is it equal to 0, students? No, it never becomes 0. It won't be 0. Because again same example, is it possible to subtract all soil particles from all stars? No, we cannot do that. Is it possible to subtract all soil particles from all stars? No, we cannot do that. That means not defined. You got some idea about not defined or undefined forms in maths. So now, here I am going to discuss next concept. Next concept, right? So prime numbers and composite numbers. Prime numbers. Primes. So what are primes, students? So numbers. What are primes? Divisible by 1 and itself. The numbers which are divisible by 1 and itself. So a number p is called as prime. An integer p is called as prime. If its only divisors are p plus or minus 1 and p. So a number, an integer p is called as p is called prime. If its only divisors are plus or minus 1 and p. So an integer p is called as prime. So if its only divisors are plus or minus 1 and p. For example, so 2. Is the 2 a prime number, students? Yes, 2 is a prime number because tell me divisors of 2. 2 only. 2 divides 2. 2 divides 2. The other divisors of 2 are plus 1 and minus 1. Both plus 1. 2 by plus 1 divides 2. How many times? 2 times. Minus 1 also divides 2. How many times? Minus 2 times. So because 2 is prime. So because 2 divides 2. Next 2 by 1 2. So 2 by minus 1 minus 2. So tell me divisors of 2. 2 P itself. 2 plus 1 minus 1. We don't have other divisors for 2. Is there any other number divides 2? No. Hence, therefore, it should be prime number. Prime number. Next prime is 3. 3 is a prime number. 5, 7. So right. Next 11, 13, 17. Right. These numbers are called as prime numbers. Prime numbers. The only divisors of prime numbers are plus or minus 1 and number itself. The numbers which are divisible by 1 and itself. Most of the people will say this definition. The numbers which are divisible by 1 and itself. One thing, students, now let's go for one more concept. Composite numbers. Composite numbers. Composite, SITE, composite numbers. So what are composite numbers? Composite numbers. So right, other than prime numbers are called as composite numbers. Other than primes. So define composite numbers. Other than prime numbers are called as composite numbers. So other than primes. Other than primes are called composite numbers. That means composite numbers will have divisors other than a number and plus or minus 1. Primes means the divisors for primes are number, that number itself and plus or minus 1. Prime numbers ke divisors ಯಾವುದು ಅದೇ ನಂಬರು ಮತ್ತೆ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ 1. ಕಾಂಪೋಸಿಟ್ಗೆ ಇವನ್ನ ಬಿಟ್ಟು ಬೇರೆ ಇರ್ತವೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯು ಟೆಲ್ ಮಿ ಕಾಂಪೋಸಿಟ್ ನಂಬರ್ಸ್ 3, 4, 6, 8, 9, 10, 12, so on. These numbers are called as composite numbers. Look at this, students. Tell me divisors of 4. 4 is a divisor. 4 divides. Plus 1 divides. Minus 1 divides. In addition to that, we have other divisor also. It is 2. 2 divides 4. Why this number is composite number? In addition to its divisors, common divisors, 6 and plus or minus 1, this has one more additional divisor. Other divisors, it will have other divisors. Tell me other divisors for 6 students. 2 divides, 3 divides. Therefore, these numbers are called as composite numbers. The numbers which can be divisible, which can be divided, are composite numbers. The numbers which cannot be divided are primes. The numbers which cannot be divided are called primes. The numbers which can be divided are called composite numbers. That is the difference. I hope. One thing, remember the following. So note 0 and 1 are. So 0 and 1 are neither primes. Neither primes nor composite numbers. 0 and 1 are neither primes nor composite numbers. So one more point. So 2 is the only prime which is both even and both even and prime. 2 is the only prime number which is even, and all other primes are odd numbers. All other primes are odd numbers, and all other primes are odd numbers, right? I hope you understood, students. So right, I hope you got some idea. So right. Okay, students. So we shall have more discussion, more basic classes in that next class. So more discussion about basics in that next class. We shall stop this. Thank you, students.